All right. So you guys want to ask something before start of the subject, or we gonna discuss water resources engineering today? You guys have any questions before starting?
Hi, Manidhar. This looks like a quite a huge chapter or subject, I must say. How many classes do you plan on taking for this?
Oh, I can say 5 to 6 classes. The subject
Oh,
seems
five to six?
huge, but 5 to 6. Yeah, for the previous batches, I
No.
completed within 6 classes.
Oh, okay. This week then. Okay, okay.
Yeah, and
So the
for
subject is
interest, like
continuing to the fluid mechanics one.
yeah. So if you understand fluid mechanics well, then water resources engineering is going to be very easy for you. Yeah, and I would like to give you a brief introduction before starting the subject. So this subject is gonna cover around 10 to 15 questions within the exam. But the thing is, out of 10 to 15 questions that you're gonna see within the exam, maximum of the questions will be from handbook. All you need to do is where exactly is the formula within the handbook. And most importantly, the conversion of units that gonna play a crucial role for this particular subject. So, if you're good at these two things, one thing is identify the formula where it is hidden in the handbook, and the second thing is unit conversion. So, if you're good at these two things, then definitely water resources engineering maximum to the maximum extent you're gonna secure like 80 to 90 percentage marks for all the given questions. And also, the tail part for this particular subject is environmental engineering. So, even environmental engineering questions will be from the handbook itself, and here, one other thing what you have to keep in your mind is while dealing with environmental engineering. The disclaimer is for environmental engineering. So, environmental engineering itself a special branch. As like we are civil engineers, there are environmental engineers as well who are going to take this FE environmental engineering exam. So, if you look at number of pages given for environmental engineering, it's gonna exceed beyond 80 or 90, somewhere around like that. All we need is couple of pages, like 5 to 6 pages for our particular exam. So do not get anxious when you look more number of pages than required. So we just we are just going to be limited for the pages that are essential for us, not more than that. Okay, and not to kill too much of time here. All right, taking you to the syllabus content. This is the syllabus content. Okay, and also I got you the syllabus for fluid mechanics as well. Okay, let's go with the contents of water resources engineering and environmental first, and also let's give a look to fluid mechanics as well. You will understand why I brought fluid mechanics into the picture too after we discuss the syllabus here. Okay, the first thing is basic hydrology. It gonna discuss about the concepts of the basic rainfall, runoff, some infiltration, catchment area. These are the basic stuff that we're gonna discuss with hydrology. And coming to basics hydraulics. Already, you guys understood what is basic hydraulics in fluid mechanics from the topic of flow measurement. The same formula, the same concept we're gonna reuse here. And interesting part is the same formula is provided to you within the subject of fluid mechanics, and also the same formula is provided to you within the subject of water resources engineering. So, for example, if you enter Manning's equation or if you search for Bernoulli's theorem within the handbook, you're gonna find it in couple of areas, like one in fluid mechanics and the another one in water resources engineering. Wherever you find it, the formula is going to be same. That's totally fine. And coming to pumps, there is no specific topic that is dedicated to pumps, but you will be able to do it by the funda or from the fundamentals that we discussed within the class. And similarly, all the others as well: water distribution system, flood control, storm water collection system, groundwater. For all these five concepts, you gonna have direct formula from the handbook. All you need to understand is some tables, charts, and how to get the maximum out of the given formula. And the last three topics: water quality testing and standards, water and wastewater treatments. The last three topics, they solely belong to environmental engineering. Okay, and you guys got to use handbook 10.5. If you guys are still with handbook 10.4, stop it and get the updated version, which is 10.5. And as time passes, like this is 2025 July, if you guys are about to give your exam in the second quarter or first quarter of 2026, then you guys have to look for the updated version of handbook. So it is not sure when they update usually. So frequently or periodically they're going to change it, which we are not sure about when they change it. It is up to NCEES when they change the version of handbook. And also you have to pay attention to the syllabus as well. They may add few topics or they may delete few topics too. All right. So now we're going to discuss our first topic. But before discussing first topic, I would like to make a quick tour from the handbook so that you guys will be able to understand what are the things provided to us for the subject water resources engineering from the handbook. Okay. So I believe it is 290 page. Yes, it is. And I'm just making sure. Are you guys able to look handbook on my screen?
Yes.
Right, sir. And so this should be the protocol of our session. Like I request you guys, please unmute yourself. You should be free to speak whenever you want to speak. If you feel like there is some background noise at your room or at your place, try to sit in a calm area and try to unmute itself. The maximum you try to answer, the maximum you will be able to understand. And also, if you're not able to sit in a calm area, then that's fine. You can mute yourself, but as much as possible, unmute yourself. So that's how the class gets, the session gets interactive and we can move at a good pace. Okay. So, as said, these are the pages from 290. Starting from 290, you're going to see the topics are related to water resources engineering. Okay. And what do they say is environmental engineering. So these two lines are not available to you within the handbook 10.4 version. These two lines are extra added here in 10.5. Similarly, there will be a few other lines extra added here and few other lines are omitted. So I recommend you guys, I suggest you guys better go with the version 10.5, but not the previous versions 10.4 or 10.3. All right. So here are the formulas. Let's make a quick tour, and when we go to the concept, we'll jump back again to the handbook again. So here are the things. Here are the things. They will give us few variables or few inputs within the question, like precipitation, infiltration, or intensity of the rainfall, storage capacity, curve number. We're going to discuss what is curve number. Okay. We guys in our bachelor's we did not pay much attention to the curve number, but we're going to understand what is a curve number here. So they're going to give certain inputs for us, and accordingly we will be able to calculate the runoff with the help of the formulas. And we got to choose, or we have to identify which formula is required for the given question. That you will be able to figure out by the end of this session, or by giving some amount of practice. But I assure you guys, if you pay attention, then by end of this particular section, this particular today's session, you will be able to understand which formula you have to use in order to calculate the runoff. Okay. They may either give you NRCS within the question or SCS. If not, they're gonna give you with the title rational formula, or else they just give you some inputs, inputs like area, rainfall intensity, and accordingly you got to choose formula. Okay. So for say Q equal to CIA here, but there is no S here. When I say yes, it is going to be maximum basin retention. So when they give you just I and A values, you got to choose this formula, but not any other formula here, because in these particular formulas, or from the set of above formulas, from the set of these formulas, they are not going to provide. They did not provide any I within these formula, within the set of these formulas. So if you see any I value, which is rainfall intensity, then you got to jump to rational formula. Most likely, they're gonna give you which formula you got to choose for the given question. Like either it can be rational, or they may give you NRCS. When they say NRCS, this is the one. Okay, so you will be able to figure out with some understanding. Okay, and question to you. Here they say Q equal to peak discharge CFS. What is CFS stands for?
Cubic for
Here
cubic
this
feet per second.
cubic feet per second. Yes, you're right, sir. And when you got to convert this cubic feet per second to add cubic yard per second, how you gonna convert it? So my question is, if it is 54 cubic feet per second, how
Divided by
many
27.
divided by 27? You got it. So when you are converting cubic feet to cubic yard, you're gonna divide that with 27. Okay. This is because you know that one yard equal to 3 feet. And so if you're cubing it, it is going to be 27 cubic feet. And here it is 1 cubic yard. In order to understand 1 cubic feet in terms of 1 cubic yard, you're gonna do this. And for suppose if you forgot that 1 yard equal to 3 cubic feet, if you don't know, or if you think that if you don't know that 1 yard equal to 3 feet, 3 linear feet, then what you can do is you can jump to the first page or initial pages of the handbook where you will be able to figure out the conversions from one to another. Okay, from add to feet or from feet to add. That thing you will be able to figure out from the initial pages of the handbook. Okay, you can flip to that page and you can do that unit conversions too. Okay, so here in this particular subject, pay attention to the units. Not only this particular subject, for the entire exam you got to pay attention to the units. And most importantly, within the exam, all the four options that you see in the exam, one or the other way you're gonna get that answer, you're gonna get all the options. But the thing is, you have to get the right answer. So you're gonna get the right answer when you do the correct application of units. And the next thing is hydrologic mass balance budget. So you need not to remember this thing or the title that is provided to you. All you need to understand is you may be asked to calculate what is the storage, or they may give you few of the values here and you got to calculate one other value. And what is this equation stands for is there there will be some rainfall, and when there is some rainfall there are some losses as well. Okay, so when there is precipitation there will be some losses as well. When I say losses, losses can be in terms of good number of reasons, like it can be because of evaporation or
Water runoff,
evapotranspiration. Yes.
runoff water, infiltration.
Y- yeah, runoff, infiltration. And feel free to discuss whatever you feel like talking. Please open up. So there are some inflow of water and there are some outflow of water as well. So what you understand from this equation is you got to add all the inflows, which is precipitation, discharge inflow, and this is through gravity. Okay, so you're gonna plus all the inflows and you're gonna subtract all the negatives. And you, if you don't know what is q out, then those values are provided to you, or those variables are described to you bottom of the formula. Okay, understand the concept. You need not to understand how the formula is obtained, but just understand the concept so that you will be able to solve the problem. And the formulas are provided to you within the handbook itself directly. Okay, the next thing is pan evaporation. So what is the concept of pan evaporation and why we need it? Any any wild guess why we need this concept of pan evaporation?
That
So when
is
I
like
say
how
pan,
much it
mhm,
is like how much water going to be evaporating.
yes, you are right. You are absolutely right. For suppose this is a water body. Okay, a water body of a good size, for say 100 meters by 100 meters. So as a water resources engineering, as a water resources engineer, or as a civil engineer, or as an environmental engineer, you got to understand what is the evaporation rate from this water pond, or from this particular water pond. So what you do is you're gonna put a pan in a specific area in this pond, and you're gonna put some water within this pan. Okay, after a few hours, so they're gonna do days of observation. So how it goes is they're gonna take 1 hour of evaporation, similarly 24 hours and 48 hours. This interval is subjected to the environmental engineer. This interval is not a specific thing. So what they usually do is after a period of time, they're gonna understand the evaporation laws that happen from this particular plan. Based upon the evaporation laws that happens from this particular plan, they're gonna understand the evaporation laws that gonna happen for a big size catchment area. So that's the concept of pan evaporation. Whereas here is the formula. In order to understand the lake evaporation, which is given by EL, it is multiplied by the pan coefficient. And the range of pan coefficient is from 0.3 to 0.85. In case, if they ask you to calculate the lake evaporation, but they did not give you the pan coefficient value, then you're going to take it as 0.7. Okay, that's how it is. And whatever the unit that they give to you for, say, usually what they give for evaporation is they may give you a linear unit, or they may give you in terms of millimeter per hour. So something like that. You will get the evaporation rate at millimeter per hour. Okay. You got to match that units as well. Pay attention to the units. And when we jump to the problems, you will understand, or you will be able to figure out how we can pay attention to the units as well. And here is the thing, one other thing, evapotranspiration. Okay. This can possibly a theory question and a most underrated thing. Need not to pay much attention, but still, as it is provided in the handbook, just give a look at it, what it is. And what do you understand by evapotranspiration?
Transportation of water from one water body to another through evaporation.
Mm,
It involves the two things like evaporation and transpiration. These are two different processes. Like
Vapor to
transpiration, we
soil.
will see in the like while the water travels from the tree to the outlet, I guess.
yeah, that's an absolute perfect answer. We can say in such a way, yeah. Evapotranspiration is a combination of evaporation and transpiration. And what do you understand by evaporation?
Like water turning into vapor from the soil or else like water bodies.
Exactly. Yeah, water turning to vapor, which is
Yeah.
evaporation. And now here is another question. What is transpiration?
Water released by the plants.
Water released by the plants. Exact answer. Now the combination of both water released, or you can say water evaporated from plants, is called as transpiration. So now the concept of both evaporation and transpiration is considered as evapotranspiration. So how it happens is, though there is grass, there will be some sort of evaporation from its adjacent area, and also there will be some sort of transpiration from the leaves. So when these two happens in a common area, then there's a point of time you're going to pull this evapotranspiration into the accounts. But as I said, it is not of much great importance. All you need to understand is what is evapotranspiration, and they may give you a range like this. If the evapotranspiration for a certain day is 0.01 inch, and how do you classify it? Can you answer this? If the
Low, low,
evapotranspiration,
low.
okay, so how you say it? So since it is 0.01, it is in between 0 to 2.5, and hence it is low.
Yes.
Okay, but let's pay attention here. What is the unit that I provided to you?
Inch per day.
Inch per day. And what does the table say?
Millimeter per day. So we have to convert the inch to the millimeter.
Yeah, so what we're gonna do is we're gonna convert this 0.01 inch to millimeter. And 1 inch got how many millimeter? You know it. If you know it, then what you're gonna do is
25,
flip the
25 mm.
12 mm.
yes, 25.4 mm, correct? So when you multiply this, it is going to be, when you multiply 0.01 with 25.4, it is going to be,
0.254.
Is it 0.254?
0.25.
So see, I wonder something like, it is 0.01. If you multiply it with 10, then you're gonna get it as 0.1. So here what I believe is it is not 0.254, it should be 2.54 if I'm right. Or
When
no,
when we multiply
mm-hmm.
0.01 into
No, you're right.
25.4 shows
Mm,
0.254.
No, 0.254, right?
Yeah.
So here what I want to say you is that if you are sure about the multiplications without using calci, then go for it. But if not, then there is a chance that we can make a mistake like this. We may assume that it is 2.54 instead of 0.254 as we just did. So, in order to be clear on these kinds of calculations, if you are sure, then definitely go for it. If not, then the best bet is pull out your calci and multiply it accordingly. Because, per se, or if we consider 0.254 and as I said, 2.54. 0.254 it's gonna fall in the range of low, but 2.54 it's gonna fall in the range of moderate. Okay, and in exam you're gonna have all these four options. If you multiply by just like this and if you get the value as 2.54, then definitely we're gonna land up with a wrong answer. Okay, this thing I brought here personally because this is one possible mistake that we can make during the practice, but it should not be during the time of exams. Okay, and once again pay attention to the unit that is provided to you within the question and accordingly we'll be able to do it. All right, and are we good on this? It's no biggie, but still you got to understand how can this is the way the question can be. You should be able to answer it. Okay, and next thing is lake classification. We're going to discuss about lake classification within the subject of environmental when we discuss about the water quality. Okay, and we are skipping this for now, but this will be covered under environmental engineering. Okay, hydraulic conductivity does that goes to the basic hydraulics, and from here Darcy's law, well drawdown, Dupit's formula. We're gonna discuss this topic by topic. I'm just letting you know that here are the things, and also sewerage flow ratio curves. So in sewerage flow ratio curves, they may give us diameter and velocity. Accordingly, we will be able to calculate how much amount of water is required for us for a particular day within a given community. And so does this thing as well. Out of all the topics that we discuss in water resources engineering, this topic is going to be little critical. And if you understand it once, then you won't be making any kind of mistake. So yeah, and also one other important topic, it's going to be somehow related to specific energy, and so does these formulas as well. Okay, and here are the things. You're gonna look at this formula, or you might look these formulas within the subject of fluid mechanics, Manning's equation, Hazen-Williams equation, from the subject of fluid mechanics. So the same formula you gonna use here as well. So the formula there won't be any kind of change within the formula. It will be the same formula and the same units and the same terminology. No big change. So we're gonna run through all these formulas and we will solve good number of problems related to all these problems and all kinds of variations that you can expect within the exam. Okay, and you can make a note of the page numbers. We're going to end with 299 for water resources engineering and started at 290. So altogether it is going to be 10 pages. So if you are thorough with these 10 pages of contents that is provided to you within the handbook, then definitely you will be able to answer 7 to 8 questions within the exam. All you need to know is where is the formula and which formula you got to use for the given set of or for the given question. That should be it. Besides that, as I said, and as I emphasized, pay attention to the conversion of units. All right. So here is our first topic, which is basic hydrology. Okay. So we're gonna discuss one by one. Okay, and you all know what is evaporation. Need not to discuss much on it. But I would like to ask you, any of you, please, if you know what is condensation, Can you please let us know what is condensation is?
When the evaporated water cools down and settles back into the water body.
Perfect. So yeah, that's condensation. Basically condensation is the reversal process of evaporation. And as you said, yeah, the water is getting cool and come back to the earth's surface. And the process of coming back is called as precipitation. The process of turning that gas molecule into liquid molecules is called as condensation, and the process of falling down is called as precipitation. So, what is sublimation? Okay, I just want to let you know that sublimation is not of that great important, but sublimation is the process of sublimation means solid particles they directly convert into the vapor without converting to liquid. Is there any such example which you can let me know?
Yes, sir, dry ice.
Dry ice, exactly.
Camphor.
And
Camphor.
yeah, camphor as well. Okay. And what is
No,
meant by transpiration? Is camphor no or no to what?
No, he said snow.
Oh, snow, you said. Snow, it got to convert to water in the first place, right? I mean, snow, it converts to water and then it got to evaporate as gas molecule. So I don't think snow falls into the concept of sublimation, but yeah, as you said, dry ice and camphor too. And yeah, transpiration. So
in cold areas, snow get vanished without converting it to the water.
is it? So in that case, maybe yeah, you can say that is a part of sublimation. But as far as I see, the snow that gets frozen, what happens is at a certain temperature or due to the regular hot days, that frozen ice gonna convert as water and it gonna run as per the slope that is provided on road. But if you say in certain areas, then those certain areas are exceptional. They may exist. I'm not completely sure about it, but yeah. And transpiration. Transpiration is basically evaporation, but it's gonna happen from vegetation area. Okay. And runoff. What do you understand by runoff?
I mean, water flowing down. Well,
Water
Yeah,
running off the surface.
water running off the surface. Both are right answers. Yeah, as you said, runoff are divided into two different classifications. One is vertical runoff and another one is horizontal runoff. Both the answers are right. So there can be, due to precipitation, there can be excess water, and that excess water can flow horizontally on top of earth's surface, which is considered as horizontal runoff. And similarly, due to the porous nature of the earth's surface, there can be some infiltration. It gonna happen as a vertical runoff, and after running for a certain distance, they're gonna run from the internal layers. Okay, so if there is runoff on the top surface, then it is considered as a horizontal runoff, and if there is a runoff downside, it can be called as a vertical runoff, which is also termed as infiltration. Okay, both answers are right. So that's how I mean these are the major contents of hydrology. And now this is just for your understanding purpose that there can be certain factors which affect all the topics that we discuss. So these are the important things, like there are certain factors which going to affect infiltration proper concepts such as soil properties based upon the surface cover, soil saturation, and rainfall intensity. Not just limited to this, there might be something else, but these are the major things that we're going to discuss. And how does surface cover going to affect? So, for example, there is a big plot, or there is any plot, or there is any city. So, this is a community which I'm just letting you know. Okay, there are buildings in a community. You're gonna see buildings which are built with concrete. Okay, in between buildings, or on the outer side of the buildings, you're gonna have some vegetation area. Okay, I'm not good at drawing, but I'm gonna let you know what is this. So all the dotted area is going to be a vegetation area. Okay, and rest all area is a concrete area. I mean to say that they did concrete slab within this portion. Okay, so where you can expect infiltration to happen, whether it is going to be in an area of vegetation or in the area of concrete.
Area of vegetation.
Area of vegetation. Why is that? Why
That
is
is the
that?
ground level.
That is the
Because the
ground level.
infiltration will be more at the in vegetation, because that is the
Mm-hmm.
concrete surface, it is non-permeable, so the penetration
Mm-hmm.
won't happen. So that's why we can see more infiltration at, like in vegetation place.
An apt answer. That's an apt answer. I definitely agree with this and other answers as well. Yeah. So vegetation is gonna accept or it gonna let water molecules pass through that soil or to pass through that top surface. Whereas concrete area, it does not let water to pass through it because, as she said, it is a non-permeable membrane. Okay, non-permeable membrane. Whereas vegetation is an area where you're gonna observe some sort of pores. When there are pores, and then
Hello.
eventually, then
Ah,
eventually
sorry.
it it gonna let some water to pass through. So that's how it is. And here I would like to discuss one other thing which is not provided to us anywhere, but I mean the definition of this particular thing is not provided to us within the handbook. You got to understand what is this. CN stands for curve number. Okay, CN stands for curve number. So the curve number is nothing but how much amount of runoff. So if the curve number is more, the limits of curve number are 3200. Okay, so if the curve number is more, then it means that less infiltration, and if the curve number is less, which is closer to 30, then it means that more infiltration. We're going to see this thing as well. Okay, and as we discussed, a runoff, it is going to be surface runoff, interflow, and base flow. Okay, when I say surface runoff, it is going to be on top of the edge surface, which is a surface runoff. Whereas interflow, it is going to be infiltration. All right. And the base flow, it is like water percolates through the layers of soil, and after percolating through certain distance, it gonna run through the horizontal layers in between the bedrocks, which is considered as a base flow. And this base flow gonna join the water bodies after a certain distance. Okay. And on top surface, after rain, on top surface, there can be a running of water. Okay. So runoff can be in these three patterns. Okay. And so what are the factors that affect runoff is rainfall, land use, topography, soil type. And as I said, this is just going to be for your theoretical purpose and just to make things clear for you that these are the things. And I believe so. No questions might be asked related to these particular concepts because you got good number of formulas that are interlinked with this particular subject. So you can expect good number of questions related to the formulas that are provided to you within the handbook. And so I don't want you guys to be surprised, but if you see any kind of such question, then you should be able to answer it as well out of the fundamental knowledge that is existing. So you should be able to answer the thing as well. Okay. Now, so this is one theory question that I framed for you in case like you can expect these kind of questions too, but very minimum. Read the question to yourself. You're gonna give me the answer.
Evaporation.
Evaporation. So no explanation needed. So the question is, which step in the hydrologic cycle converts water from a liquid state to gaseous state? The answer is evaporation. Whereas condensation, it's a reverse process of evaporation. So does the precipitation as well. I mean, the precipitation is a process of by which condensed water in the atmosphere falls to its surface. That falling concept is called as precipitation. Okay. And now let's jump back to the handbook again. I'm taking you back to the handbook. Okay, where are we? Jump to the page number 290, and if possible, guys, please have two screens. One is handbook on your screen itself, so that while discussing, you guys should be able to scroll the pages of handbook to yourself and figure out where are the things and what exactly are the things. Handbook is the key for you. So the thing is, having minimum knowledge related to civil engineering and having good number of years of experience, you should be able to solve all kinds of questions. If there is no time limit, though they give you handbook, and if there is no time limit, then you should be able to solve like 80 to 90 questions without any problem. But the thing is, you got to solve within the stipulated time. So when I say stipulated time, if you pull down the numbers, it is going to be 2 minutes 54 seconds for each question, to be precise. So roughly 3 minutes. So within 3 minutes, you got to find out the formula where it is located, plug in the values, check out the result, convert the units. That's all we need to do to the maximum extent. Okay. All right. So here we are rediscussing about the concept of runoff. So does the peak discharge as well. Okay. Okay. Question to you: Is runoff and the peak discharge, are they both same? Mm-hmm. All right. So the
I
question can
think
be framed in.
it won't be same.
No, it won't be
But
same.
like the base flow, everything adds, then there will be increase in the peak discharge.
Mm-hmm.
So I'm thinking in
Yeah.
that way, they might not be same.
Yeah. So yeah, and I would like to hear one other answer as well. Someone is about to say something.
It is like how much water is leaving, then we can call it as runoff. But when it comes to the peak discharge, how the water is flowing to the maximum point in a particular time.
Yeah, you're right. You're absolutely right. And one major difference here I would like to let you know is both the answers I got from you are absolutely fine and they're correct. So I would like to add one other point to your thoughts here is that so the runoff is calculated in terms of inches, whereas the discharge is calculated in terms of CFS, which here it is going to be volume, whereas the runoff is calculated in linear dimension in terms of inches. Okay. The question can be in any format. They may ask you to calculate what is the value. The question can be in any format. They may ask you to calculate what is the value of Q directly. If not, they may ask you what is the runoff. If not, they may ask you what is the peak discharge. So if they ask you what is runoff, then this is the formula. This is the formula. If they ask you what is peak discharge, then this is the formula. Again, if they mention rational formula, you got to jump here. If they mention NRCS, you got to jump here. Pay attention to the details, what they are providing to you, and accordingly you got to choose formula. Do not kill yourself if you are unable to figure out which formula you got to use, then that's the minute you got locked up for that particular question. So give good amount of practice to the questions that you see and understand which formula or accordingly. This is not limited to the particular subject that we are discussing. This is for every subject that you're gonna see for your preparation. Okay. So I hope we are good here, right? Any questions? Okay. All right. So they're gonna give us the value of precipitation. They may give S value, which is maximum basin retention. And for NRCS, all the values are in linear dimension. Whereas the curve number, it is dimensionless. It doesn't have any kind of dimension. Okay, that's just a number. That's just a number. Okay. So they will give you the required input, or else they may give you the value of runoff. They may ask you to find out what is the value of precipitation, or they may ask you to find out what is the value of S. You will be able to calculate that. Okay. And also one other thing is rational formula. What is the general formula for discharge? What do you understand the general formula for discharge? Whatever comes into your mind. What
Volume
is the
by
formula for discharge? Mm-hmm.
like
You're saying?
in fluid mechanics,
Mm,
the volume
Flow of
by
water
time
percent.
we will consider.
Q is equal to AV.
Wow. Okay, I got Q equal to AV, and somebody said volume times area. That's absolutely fine. And I missed one other answer.
Flow per second, something like that.
Yeah, flow per second. Absolutely fine. How much flow is happening within a unit period of time? It can be second, or it can be hours, or it can be any course of time. But Yeah, this is the usual conversion that we follow. Okay, Q equal to AV. That's one good answer that I like. Here it is the same. Q equal to CIA is the same. Whereas C is the coefficient. It can be, it is some bloody coefficient that we don't know at the minute, but it is a coefficient. Okay. Whereas A stands for the same area that you say, and V is velocity. But here that particular velocity is the velocity of rainfall. Is the same formula. You know this formula where discharge equal to A into V is the same formula applied in a different format where I equal to is the velocity of rainfall, which is called by the term rainfall intensity given in inches per hour. Okay, and C is some constant, which is runoff coefficient. And this particular runoff coefficient value will be provided to you within the exam. For your understanding, the coefficient of runoff, it is going to be in between the limits of 0 to 1. Not only this particular runoff coefficient, the maximum coefficients value that you see in civil engineering gonna be in the range of 0 to 1. Okay. First say in exam, if you got like calculate the runoff coefficient, and if you got couple of the values are beyond 1 and beyond 0, so then definitely those options are not your answers. Those should not be your answers. Okay. So not to kill too much time here, we are jumping back to the problems. Okay. Here we are. The same formula, I pull it here just to let you know about curve number, since curve number is not provided to you in the handbook, and curve number is a dimensionless parameter. The range of the curve number is 30 to 100. This is not provided to you in the handbook. This is not in the handbook. Okay, but that is better if we learn about it. Okay, and this is a summary. Though you do not remember it, it's no biggie, but understanding it gonna benefit you while solving the problems. Okay, a higher curve number closer to 100, it means that less infiltration, so which is a concrete kind of area. Okay, whereas the lower curve number, it is going to be vegetation area. And guys, before solving problems, is that okay if I take like 10 to 15 minutes extra for today so that we can close the topic of basic hydrology? Definitely we're gonna take half an hour from now.
Okay,
Is it an S?
fine. Yeah, it's
Okay.
fine.
All right. Okay. Okay then. So see, the participants are 21. If it goes, we're gonna continue the session if the participants are more than 15. All right. Just 10 to 15 more minutes. That's it. Okay. So read the question to yourself. We're gonna solve it together. Okay. What does the question say? It says a total of 16 inches of rain poured on a watershed. If the maximum storage is 1.6 inches, then the total runoff is very nearly. Okay. Here I provided you the formula, but do not look at the formula that is provided to you. How sure are you to pick the formula here? So there are a couple of formulas within the handbook. One is NRCS formula for Q, and the another formula Q is CIA. So what makes you to go to the exact formula with respect to the given variables? Is my question clear or should I repeat it?
We provide the maximum storage, so based on that.
Yes. Yes, and they gave us maximum storage, which is 1.6 inches. And what else makes you think of it?
And also they haven't
What
given the coefficient.
exactly? Yeah, they did not give C value. They gave S value. Most importantly, what they ask us to calculate?
Total runoff.
Total runoff. When they ask total runoff, which Q stands for total runoff here? Whether the one in the NRCS formula or whether the one in rational formula?
NRCS.
NRCS. Flip the pages of handbook to the page number 290 and you will be able to see Q equal to this particular formula stands for where Q stands for runoff. Whereas the other Q, which is equal to CIA, it is going to be a rational formula that stands for discharge. That is going to be for peak discharge. Okay. So here are the things. They gave us P value and S value, which is going to be 16 inches and 1.6 inches. So from this particular formula, you will be able to obtain the value of runoff. And what should be the unit of Q here?
Inches.
Inches. You're right, sir. So what is the value you are getting here for this particular thing? If you substitute in, if you plug in the values, pay attention to the brackets as well.
14.22.
14.22. All right. So it can be 14.22. It can be 14.22 inches. So, okay. In exam, it can be in such a way. Then the total runoff is very nearly in feet. And in the options, they may not give you any units. If that is the case, the options will be like, they're gonna give you one option which matches the feet and another option which matches the inches as well. So looking at the options, we may think that 14.21 is the answer, but in case if they provide feet in the question, then you got to convert that. Always give a second look to the units. Emphasize to the units what is requested in the question. If they did not ask, then at least they will provide the units within the options as well. Okay, so that's one thing. And I would like to give you a rule of thumb here. So the runoff is usually considered as the extra water or the extra rainfall that is left out from the precipitation. Here the precipitation they provided as 16 inches minus storage, which is going to be 14.4. This is the rough answer. Like, just in case if you're not sure how exactly the runoff is calculated, then you know by the basic funda that runoff is the excess water that is flown out of the precipitation. Okay. And if the precipitation itself is 16 inches, then your answer cannot be, your runoff cannot be more than 16 inches. So here in this particular example, option C and option D, they should not be your answer for sure, because in maximum of the cases, unless and until the area is very wet, so in maximum of the cases, the runoff is lesser than the precipitation. All right. Are we good here for this particular formula? Okay. Moving forward. So here is one interesting question. If you solve this, then I admit that you will be able to solve any kind of problem that is related to basic hydrology. Okay. For now, we are solving it together, but you're going to see similar problems within your practice as well. Read the question and understand it. Let's solve it together. The question says, an urban area consists of 15 acres of land space with curve number 70 and 4 acres of paved road with curve number 97. If the total precipitation is 16 inches, what is the approximate runoff? What is the formula that we have to pick here? What are the values that they gave us within the question?
Q is equal to
So
CIA.
Q equal to CIA. Why is it so?
As they
In the question
provided
they
the
gave,
area.
they provided well the area. They provided area. Agreed. So don't we have area within the? Don't we have area within the NRCS formula?
No.
Yes, they did not provide, but still, what they ask us to calculate?
Approximate runoff.
Runoff.
Runoff means
And runoff means which formula you got to pick it up?
NRCS.
NRCS.
NRCS. Absolutely fine. And when you're picking Q equal to CIA, what is the unit of Q?
Inches.
When you're
Cubic feet.
Yeah, when you're picking a rational formula, it is going to be cubic feet per second. Whereas if you're picking NRCS formula, the unit of Q is inches. All right. So you will be having good number of clues provided to you, which formula you got to pick it up. Okay. So now which formula goes good for, we got a clarity that we have to use NRCS formula, but in NRCS, which formula goes good? What is the formula for Q?
N equal to 1000 yes.
What is that?
Curve number. What is the curve number?
So in question they gave us area 15 acres of land space And also the K was 4 acres of paved road with 15 acres of land space with a curve number 70, whereas 4 acres of paved road with a curve number 97. So, what is the formula that is associated with curve number and the precipitation so as to calculate the approximate runoff? Able to figure it out? Is there any formula that is associated with curve number?
It's associated with two of formulas over there.
Uh-huh. Yeah, you are right. So now let's run back to the handbook here. So yeah, curve number, they gave us a formula. We got already curve number which is provided to us within the question. In order to calculate Q, what are the variables that we require? One is P and another one is S. Correct? Yes or no? And do we need any other variable apart from P and S? No, right? It is just the variable P and one other variable is S. So already P is provided to us within the question and we got to calculate S. So if we are able to calculate S and substitute the value of S within this particular formula along with P, then we will be able to get the value of Q. Correct? And in order to calculate the value of S, it is going to be 1000 divided by curve number minus 10. But here is the question. Within the given question, they gave us two curve numbers. So how are you gonna do it? Like how are you gonna do in such a case? They gave us two curve numbers, right? So how are you gonna do it?
15 minus 4.
15 minus 4, okay. Okay. Question to you guys. And also I would like to pull or brush your memory. You guys attended the subject mathematics and statistics. And if you guys do not attend the mathematics and statistics, that should not be a biggie, but still, guys who attended mathematics and statistics, you will be able to answer this question. Weighted arithmetic mean. You remember this concept, weighted arithmetic mean?
Yes.
Yeah, yep.
Okay.
Yeah, 15
Yep.
into 10, 70 into 4 into 97.
I got
Exactly.
76 SCN by
Exactly.
doing that.
You guys are amazing. So weighted arithmetic mean you're gonna do that. So what is curve number here you're gonna get is A1 C1. C here stands for curve number. I just wrote it as C for your understanding. Okay, so in order to calculate curve number, you're gonna multiply area and curve number you're gonna multiply those and add them and divide
Total area.
it by area. Then you will get the curve number for the entire plot, like a single curve number for the entire plot. Okay, that's a common curve number. And most importantly, when you calculate in such a way, the curve number should be in between the range that they gave. Here the range is 70 and 97, correct? So, in the given question, the curve numbers are 70 and 97. So if you calculate a common curve number for both the lines, then it should be in the range of 70 to 97. Now let's calculate and let's see if it falls in the range of 70 to 97. Okay, A1 is 15 acres and curve number is 70 for that, whereas A2 for the paved roads is 4 and the curve number is 97, whereas the areas is 15 plus 4. So what's the curve number for both together?
76.
75.68.
Thank you. 76 point?
75.68.
75.68.
75.68.
68.
Yeah. Okay, that's a curve number. And what is the unit for curve number?
Dimensionless.
Dimensionless
It's
parameter.
dimensionless. Yeah, it's a dimensionless parameter. So no unit for that. Okay. And also, if possible, guys, please scribble down so that while discussing, you're gonna look at the things again and again. They're gonna sit in your memory. Okay, so now
Answer is C.
answer is C. Let's see if it is right or not. So we got curve number as 75.68. And what is the S value after getting the curve number?
3.16 inch.
3.16 inch. That's a good thing. That's a good thing. You emphasized on the unit. 3.16 inch. Now you got the P value, which is 16 inches. That's a common precipitation for the entire area. curve number is 75.68. At this minute, you don't require curve number because you got the value of S, which is 3.16 inch. And now you're going to calculate the runoff based upon the P value and S value. What is the formula for Q? I don't remember because it is provided to us in the handbook.
P minus 0.2s whole square by P plus 0.8s.
Okay, so if you plug in the values of P and S in here, the value should be in inches.
Yeah, 12.75.
So you're getting 12.75. Are we good on this question?
Yes.
Yes, sir. Yes to everyone.
So for
So, sir,
finding the CN number, do we have any graphs based on the graph also? Then we can we find that CN number, or we need to go with the weighted arithmetic method only for every time?
That's a good ask. So well in the handbook, there is no dedicated curve number provided to us, but in exam, they may give you graph as well because curve number, it got its own graph as well. So in exam, they may give you graph, but from the graph, you will be able to figure it out. Most likely they don't give you because a graph will be provided to you for the PE exam, but not for FE exam. That's a good ask. So if you look at the PE handbook, then definitely you will be able to see this curve number. I believe I'm not sure 100%, but yeah. So do not worry about it. But usually curve number got its own graph. You're right.
Okay.
so sir, every
The
time it gives us two areas, so we have to use this method, weighted arithmetic mean method.
Yes. Yes.
Okay.
Yeah. All right. So that's how it is. And
the value for S I got 3.21. I don't know why I don't get 3.16 inches.
3.21 is what
I take it as 75. So instead of
oh,
like
that's the
Oh,
reason.
76, I got it 76.
Okay. So that's the
Roughly,
reason.
I take it 76.
okay, okay.
So yeah, questions can be in two different formats within the exam. So like 70 to 80% of the questions you're going to see them like what is the approximate value, and few questions they will be very precise, or the questions are like very precise what is the exact value. So that's okay. You will be able to figure it out with good amount of practice. You will be able to figure it out that those will be the behavior of options as well. Okay. All right. So easy question for you.
A land of 6 acres with a runoff coefficient of 0.6 experiences of runoff.
Yeah, you can read it out loudly. Most welcome.
Oh, here he asked for the intensity. That means we should definitely go with the Q equal to CIA.
Yes, sir.
And the rational method too. So
Mm-hmm.
Okay.
I got D.
You got D. That's the answer. Everyone got D.
Convert into yak 2 per second. We got 0.8.
Mm-hmm. You got 0.8.
Yeah, I converted into yak 2 per second. We
Yeah,
got the
yeah.
discharge in
So
CFS, right?
you're right. I think so. You're right. So let's see how it
Yeah,
goes.
I I told you in CFS. That's my bad.
Yeah. Uh, yeah. So this can be one kind of questions that you're going to see in the exam. The problem is pretty simple. What they're asking is they're asking us to calculate the peak discharge in terms of cubic yard per second. Okay. So what we do is we pay attention to the peak discharge, which is Q equal to CAA, and they give us all the units, which is the runoff coefficient as 0.6 and the rainfall intensity as 6 inches per hour, and the A is in acres. Okay. As per the formula, A should be in acres and I should be in inches per hour. That's absolutely fine. We got them accordingly. Okay, so if you do multiply so, then eventually you're going to get an answer of 21.6, but the units are CFS here. Okay, they emphasized on the unit at cubic yard per second. So we got to convert this cubic feet per second into cubic yard per second. How you're going to get that is you're going to divide this by 27, and then that's where you're going to convert this cubic feet per second to cubic yard per second, where you're going to get the answer of 0.8. Okay, so all the given options, somehow or the other, you're going to land up with the wrong answer too. Once again, there should be a second check. Whatever the problem that you do within the exam, there should be a second check. Pay attention to the unit that is provided to you. I am damn sure having minimum knowledge, having fundamental knowledge and formula in front of you, calci in your hand, you gonna get the answer. And that answer is provided to you within the options. But you're gonna pick wrong option because of units. All right.
So when we're
Okay.
writing a formula, can we go with the conversions at the formula, like by taking an handbook CAA into whatever the conversions 1 feet to add square, then we can get it right away, right?
You can do it. Absolutely fine. That conversion is absolutely up to the level of aptitude that you get it. So when you say so, you can convert that inches per hour to add per second, that you can do that. So does 6 acres, you can convert that to add square. If you do so, then definitely you're gonna land up with the answer. But the thing is, you got to make it accurately.
Got it.
All right. Yeah. Okay. And the next thing, this is one other question. Okay. You want to solve this problem to yourself, or let's solve it now?
We'll solve it ourselves.
Okay. That's a good thing. This is an add-on question to this question. So if you see a land of 6 acres with a runoff coefficient of 0.6, rainfall intensity 6 inches per hour. Okay, is the same. 6 acres, runoff coefficient 0.6, rainfall intensity 6 inches per hour. But also there is one other land of 5 acres with a runoff coefficient of 0.45. Now you're going to calculate the peak discharge. So take a screenshot or photo of this. Tomorrow session, we're going to start with this question if you do not get an answer. If you get an answer, that's fine. You will be able to solve it. No biggie. You're going to apply the same formula, but you're going to sum up like, you're going to sum it up with like this. Okay, if you use this, then definitely you're going to get the answer. All right. So any questions for the day?
Here also you can apply the weighted arithmetic logic also, right?
Yeah,
Like
that's a
this.
good question. That's really a good question. I'm foreseeing this question actually. So, well, you cannot apply, but why? If you understand this, then I admit it, you understand the total hydrology concept. Here we cannot take the
We are not
arithmetic.
doing the average.
Why is that?
Because of intensity, they gave.
Okay, they gave us intensity. Intensity is going to be the same. That's for sure. But here, okay, here is the question. Here for curve number, we are taking arithmetic mean. Okay, but here for runoff coefficient, we are not taking arithmetic mean. Why is that?
Ration number. What's the reason?
You said rational
Maybe it's
number.
because of
The intensity
two
for
different
both
lands.
rainfalls is same.
The intensity for the both rainfalls is same. That is understandable. But why are you not taking a common runoff coefficient for both? Okay. Let's go back to the visualization. Okay, once again. I'm taking you back to the previous question, okay? Whoever asked this particular question, I have to appreciate this. You definitely got good doubt, that I can say. Visualize this question here. What does it say is, it says that 15 acres of land space, which is a green space of 15 acres, correct?
Is it because of like this question is comes under same land and there we are considering two different lands?
Well,
In this,
exactly.
they have
Yes,
the approximate.
that's the answer. That's the answer. So, as you said, you're right. The 6 acres, it is going to be one plot, and the 5 acres is going to be one other plot. Here, these two things, these two plots are two different plots, and hence you cannot get a common runoff coefficient here. For suppose, within the same problem, if they say runoff coefficient for a concrete pavement like this, and if they say the runoff coefficient for another bit of land like this, then that's the point you try to identify the common runoff coefficient. But here these two are 6 acres is one land and 5 acres is different land. So that's the reason you are summing up both the discharge and you're going to get the peak discharge. That's the smart answer. Yeah. But here, within this particular problem, what you are trying to identify is curve number, which is common for the entire space, which is common for the entire space. Okay. So that's the catch, where a green area got a different curve number and the paved area got a different curve number. And you're trying to get the mean area, I mean mean curve number based upon the area of exposure. I hope the question is clearly resolved. Yes,
Yes, sir. Yeah. Thank you.
thank you. Got a few smart guys in the class, good number of understanding guys, and do not get upset if you do not understand the thing in the first minute itself. Eventually, you will get it. This subject is more of a visualization kind of stuff. So, whatever the question that you read, pay attention to it. The reason I am giving you your time to understand the question is because you can visualize the question as well. So you should be able to solve this. Okay. Not paying much attention to this question. Any questions for the day? If we continue with the same pace, then we can complete the subject within 6 days, like including Saturday. And I encourage you guys to have one long session either on Saturday or Sunday so that we can cover one other subject as well. In that case, we will be more advanced. I mean, we can cover up the lagging schedule, right? See you tomorrow.